Hi guys, my name is Fortran and today we're going to talk about Newton-Raphson. Newton-Raphson is when you have an equation then you can't find any answer. For this case, you have a equation like this. Then you were asked to find what values of x give you a values of y is equal to 0. Well, if you can't figure it out, let's go together with me. What I'm going to do is I'm going to introduce you to a Newton-Raphson. So let's say you have any kind of a graph that defines an equation you can't find. For example, the graph of yours look like this. Now you want to find a point where y is 0, so it's this point here. But how on earth are you going to get to that point? Well, Newton comes up with a solution that guess a number, guess any number here. So I'm going to guess a number and call that x1, any number. So that x1 is an exact number that you know. What this means is you will know the y. Why? Because y is equal to the function of x. So you have x, you plug that x in and you get a y. Okay, so I have to move this thing here a little bit. There you go. And when you know this, you will also know the slope, right? And what does a slope give you? A slope gives you the point of a next x. I call that x2. So that x2 is closer to the answer. And you do the same thing over and over, you get really close to the answer, and that's your answer. That's it. But before going to that, how do we know where is the x2? Well, you need to know this value first. And if you know that values, you will know x2 by subtracting it from the previous x. So I'm going to write it here. Your x2, or your new x, will be equal to the older x minus that part here, which is the difference, right? Then, how do we find the difference? Well, that's easy. Let's get back to high school. In high school time, you were having fun with the rise and run. A slope is equal to rise divided by run, which means it is delta y divided by delta x. In this case, it is this part divided by this part, right? So you get that slope already. Hey, remember something? Delta y is also equal to the function of x. So write function of x divided by the difference of x, so you get slope. Then, you kind of think of something. Oh, if I want that delta x, then maybe we could switch place. In this case, a difference of x you need to know is a function of x divided by the slope. How do we know the slope? Remember something from calculus class? Yes, it is the derivative of it. So once you find a derivative of a function x, then you find a slope. Oh, we know that already, so this means fx divided derivative of function x. Oh, that's your delta x. So this means we could plug the same thing, same looking thing here, into the same equation. So your new equation will be equal to x2, your new x, is equal to x1 minus a function of x divided by the slope, which is the derivative of it. Hey, we know everything here. We know our x1, we know the function of it, we know the derivative of that function too. So this means we can find a new x. And if we keep doing this again and again, you will get really, really, really close to the answer. Ooh. You'll get really, really close to the answer, right? And which point is the answer then? The answer is when the points are really, really close to each other. And the difference of it is like lesser than 0.0001, then that's it. That's your answer. Oh, that's the end of our math thing. Okay, so how are we going to code this? Maybe we need to focus on something you call a function. A function is when you have something and you call it function. But in Python, you're going to call that a def. Okay, let's go to the computer. Here we go. Never mind this. I'll use the camera. Okay. Okay, guys. So welcome to Python, and today I'm going to use a collab by Google. First of all, I'm going to have the DEF, the definition of something, and that def of mine stands for a function of x. Our function of x, or any function, have to return something. In this case, we want to return an equation, and our equation is x to the power of 3 plus 2 to the power of, ooh, come here, 2 to the power of x minus 2, right? And we also need the same thing for the derivative, so you just write, hey, we need derivative of it too. Let's say it's a df, okay, df of x. Then you need to return something. So calculus part, you need to return 3 times x to the power of 2. Then you also need to plus it with 2. That's it. What do you do next? You might want to guess a number, as Newton said. So you can guess any number. I'm just going to guess that as 1, for example. Write that x0 equal to 1. Then you want it to loop, so it goes on until it finds the answer. So that loops thing, you call it for. For I in range of something. In this case, in range of 100. This means if it goes 100 times, it doesn't find answer. Boom, that's it. Computer can't find it in this case. So cross our finger to have it clear. Okay, so that for thing here, you just want to tap in so you know that it will work inside there. What you need next is you need a formula. So a formula is that a new x is equal to the x, the previous x, minus the function of x, which we already defined it, divided by the derivative of it. Here we go. Then what do we do next? We want it to be print so that we could see it. Just write print, parenthesis, parenthesis, please. This is what you call a string. String is something like a fixed value for you. When you want to add other things, just add comma there. I want to have my x of 0. Oh, one thing you need to know is that every definition in Python or any for, you need a colon after that. So colon, 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 please. There we go. So we need an x of a 0. Hey, function. So we need x of a 0. This means I'm just going to write function of x0. Then we also want that to be closed. So closed and equal to a new function, which is our derivative of it. So write df of x0. There we go. Then what you do next is that you want to have it stop somewhere. So where do we stop again? Remember what we talked in the first. We need to find it when it's really close. So just write absolute. Why absolute? So you can make sure that either way it goes, it doesn't have problems. So absolute of x0 minus x, if that is like lesser than, let's say, 0.001 or anything, just stop. So if that happened, you want to write if here. If that happened, then you want it to break. So break, B-R-E-A-K. Okay, so what do we do next? Well, if everything happened, we want it to place a new values, the old values to the new values. So that x else, okay, colon. Okay, if things goes like that, just write x0 is equal to x. Oh, cross our finger. Oh, it comes. So that's the answer. At that point of 0.003 something, that's the answer. Anyway, if you want to have a look of how it looks like on a graph, we have a solution for that. Oh, it doesn't come again. Anyway, here it is. Thank you very much for watching. Hope you get something from this video. Bye bye.